Okay, so 9.1, we are only going to do 9.1 and 9.3 in this chapter. That's all we're doing. Okay, we will have a quest over it probably Tuesday next week. Okay, so we're only doing 9.1, 9.2, unless I decide to put all of what we're doing now with the next because it's small. Okay, so we are going to use polygons in the coordinate plane. So a polygon is a figure that has vertices and straight sides, correct? A circle is not a polygon. A rectangle is, a square is, a trapezoid is, kite, a rhombus, quadrilateral. So those are all polygons. It's a closed figure that have vertices and straight sides. Okay, it says, what is AB? Well, other than AB being a line, it's the length. What is the length? Well, if it was straight, we could count it. Just 1, 2, 3, 4, 5, 6. But it's not, is it? Nope. So we need to use the distance formula, which you should have on your sheet. So what is the distance formula? So D equals x2, the square root of x2 minus x1 what? Squared.
Plus y2 minus y1.
Squared. And we've used this before, yes? Yes? But you are going to use this on every single problem today. On this problem, actually, how many times? 1, 2, 3. Okay, so you're going to be doing slope formula and distance formula on every single problem. But this one just says, what is AB? So AB equals the square root. Now, we're going from A to B. Does it matter which one's 1 and which one's 2? No. I'm just going to go top to bottom. So it's 1 minus 3 squared plus 6 minus 1 squared. Now, if it was me on my paper, I would have 2 squared plus 5 squared. I would not write this step. You don't have to write every single step, but do you have to write enough that I know you're using the distance formula? Yes. Okay, so 1 minus 1 minus 3 is? 2. And technically it's a negative 2, but I'm going to square it. And negative 2 squared and 2 squared, what do I get? 4. So does it really matter that it's a negative 2? No. But I'm just going to, I'll write it this time. Okay, plus 6 minus 1? 5. So I have the square root of 4 plus 25. Correct? So I have the square root of 29. Now, can I reduce the square root of 29? No. That's it. Are you going to get really good at the distance formula today? If you do your homework. Okay. What point bisects? What does bisect mean? What?
Like a cross.
Bisect means it cuts it into what? Half. Do we have something that talks about half? The midpoint formula. So this is going to be midpoint. So what is the midpoint formula? Because you were supposed to write it on your piece of paper.
M equals x1 plus x2 divided by 2.
Okay, so midpoint is x1 or 2. I put 2 just because I'm used to the slope. Doesn't really matter. No, because I'm adding, right? And then y2 plus y1 over 2. Remember when we did this, I said it's the average of the 2 points, right? Because I come with a point. When I'm done, I have an x and a y. Okay, so I have 1, 6, and I have 3, 1. So the midpoint is 1 plus 3 over 2, comma 6 plus 1 over 2. So 1 plus 3 is
4.
4 over 2 and 7 over 2. But 4 over 2 is what? 2, comma 7 over 2. And 7 over 2 is 3.5, isn't it? Okay, so let's see. So it says 2, 1, 2, and up 3.5. 1, 2, oops, over 2. 1, 2, 3.5. Is that the midpoint? Does it hit it right there?
Something like that.
Yes. So this is the midpoint. And it bisects. So when it asks for bisects, is it asking you just for the midpoint? Yes. Another formula you had to put on your sheet, didn't you? Wonder why. Now the next one, it says, what is the slope? So what is the slope formula?
Rise over run.
That's not the formula. That's what's-
y2 minus y1 over x2 minus x1.
y2 minus y1 over x2 minus x1. So we need to do AB, BC, and AC. So AB, and we're using 1 and 6 and 3 and 1. So I'm just using A for the first one. So it's 6 minus 1, right? Over 1 minus 3. So I get 5 over negative 2. Or negative 5 halves. It doesn't matter if the negative's with the denominator, but I personally do not like it. It drives me nuts. The negative can be in the numerator or in the denominator, but can it be in both? No, because a negative divided by a negative is a positive, and that would be changing it. Now, we did the slope formula, but we have a picture. Did we really need to do the slope formula? Could we have just counted it? So let's count BC. So B to C. So we go up how many? 1, 2. So 2. And we're going right, which is positive direction, correct? 1, 2, 3, 4, 5. Okay. So that's 5. So you guys do AC. Kind of use the picture in your book. It will be easier.
Oh my God. That's right what I
I got negative 3/7. What'd you guys get?
got. Sure thing.
Negative 3/7. Now remember, if I'm looking from left to right, do you see how AC goes down? That should be a negative slope, shouldn't it? And we got negative. BC goes what? Up, so it should be a positive slope. Now I have a question for you guys. What kind of triangle is this?
Right.
It's a what?
Right.
How do you know?
I have that on my samples.
Because it has a right
It
angle.
doesn't have a right angle.
Well, but guys, I have a slope of negative 5 halves and a slope of 2/5. What's the relationship with those slopes?
They're reciprocal.
They're reciprocals, and one is negative and one is positive. So when I have reciprocal negative slopes, what are the two lines? They're perpendicular, which means they meet at a what? 90-degree angle. So this is a what? Right angle. So this is a what?
Right triangle.
It is a right triangle because these two slopes, when I do negative 5/2 times 2/5, I get -1, don't I? Don't I?
Yes.
Meaning that these two lines are perpendicular, and this is a what? It's a right triangle. Look at that.
I was right.
So are you going to have to remember perpendicular and parallel also?
Probably.
Yes.
Yep. Because it says, and what does this tell you? Well, these slopes told me that it's a what? Right triangle. If you do not on your sheets have perpendicular slopes or negative reciprocals of each other, should you add it to those sheets? That is a yes. I will give you a second if you need to add those to your sheets. No one needs to add that?
I don't know what.
That on perpendicular lines, do you need to add that the slopes are negative reciprocals of each other? I think it's on the third page, isn't it?
Second.
Second?
Parallel.
Parallel, what do you know about the slopes? If they're parallel, what are the slopes,
You're
guys?
not intersecting in
Yeah, but what about the slopes?
no negatives.
They're exactly the same. So parallel lines have the same slope. If you don't have that, should you put it on your parallel line one? Cooper, in your parallel line, do you have parallel lines have same slopes?
It's on the front page.
If you do not have parallel lines have the same slope and perpendicular lines have the negative reciprocal slope, should you add those?
Yes.
Because is that an important thing to know?
Yes.
Okay, am I good? Sorry. Okay. The next question says, what kind of triangle is this? Is it equilateral, isosceles, or scalene? So what does equilateral mean?
All three sides of
All sides are the same.
Angle.
Same sides. What?
It's probably a scaling.
What's isosceles mean?
two
Two
sides.
sides of the same.
Two sides are congruent, right?
Scalene, all three sides are different.
And all different. So, in order to tell this, we need to find the what of all three sides.
Slope,
Not the slope,
side.
Agree.
the length. Okay? Because we're talking about lengths, right? So we need to figure out the lengths. So we have to do x, y, y, z, and zx. So we'll do x, y together, and then I'll let you loose on the other ones. How's that sound? Okay, so x, y. I'm just going to go from top to bottom again. So 5 minus 1 squared plus 8 minus 2. Am I going too fast? No. So 5 minus 1 is what?
4,
Squared is?
16.
See how I can do some work and then do some work in my head? See that? So 8 minus 2 is 6. Squared is 36. So that's the square root of, I think, 52.
Yes.
And I probably should simplify it then, huh? So, well, 4 goes into it, doesn't it? So square root of 4 times the square root of 13. What's the square root of 4? 2 square root of 13?
13.
No, it's 2 square root of 13. Because the square root of 4 is 2.
6.
What?
6 times.
No, that's the answer.
That's the answer.
Oh, I was saying, it's like just 13. And you're like,
No, the square root of 4 is 2. And the square root of 13 is the square root of 13.
that's what I'm saying. And you're like, no.
I did not say no.
I was saying just 13.
Okay. It's not just 13. There's a 2 there.
Ah, 13.
Okay. When you said just 13, I thought you meant to drop the 2. Okay, so you guys need to do YZ. And what else? XZ.
Do we do YZ too?
Mm-hmm. Because in order to see the relationship of the sides, we have to do all of them. There's trash back here, Brian.
Are you busy?
Oh, quick.
Okay. I just want to go over all my periods on like these ones to make sure I'm right. Okay.
So you should take this minus a negative 3 pi over 8. So it's pi.
Okay.
And then this one minus pi over 12.
Yeah.
So this would be 12,
You.
right? No, 9.
9.
So it would be 8 pi over 12.
Yeah.
So 4 pi, no, how about 2 pi over 3?
Yeah. The periods are just a part of that.
Okay, now this one, if it was me, I'd do this. Draw that on there.
Yeah.
Pi.
Okay.
So once you do that, you just see it's pi.
Yeah.
And then this one, you're gonna subtract a negative. So it'd be 3, so it'd be 4 pi.
My fiance, Andy.
So 2 pi over 3.
Great. Thank you.
Welcome. Okay, did you guys get the square root of 13 and square root of 65? Okay, what was I doing down here? What's this?
Probably down.
You tried to break it down.
I tried to break it down, it didn't work, did it? Okay, so I have 2 square root of 13. I have square root of 13, and I have square root of 65. So what kind of triangle is it?
Scaling.
Scaling.
They just hold you that. Could you?
Okay, now I'm going to ask you for the perimeter.
What do you think I am?
That was on your sheet too, yes?
Sure.
What is a perimeter?
The outside.
The outside, add them up, yes?
Yeah.
Okay, so I have 2 square root of 13 plus square root of 13 plus the square root of 65. So can I just add these all up?
Sure. No.
You can add the square roots.
Aren't there one on the outside?
There is a 1 right here. Yep. Can I add all the square roots?
No.
No, I can only add what?
13.
The 13s, right? They have to be the same, don't they?
Yeah.
So I have 2 square root of 13s and I have 1 square root of 13s. I have how many?
3 square root of 26.
No. I have 3 square roots of 13.
Son.
Plus the square root of what?
65.
65. And you would put any unit, right? Like if it gave me a unit, I'd put it on there, wouldn't I?
Yeah.
Okay. So you may have a question that asks you what kind of triangle it is. Well, then you had to find the distance of all of them, right? All the sides. Just so. Well, what if it gave you and it said, what is the perimeter? What do you still have to find?
Outside.
All the lengths, don't you? So you are going to be doing distance formula and slope on every problem. So if you're not understanding quite what's going on, just do the distance formula and the slope, and then you can come in and ask a question, correct? But those need to be done on everything. Got me?
Yeah.
Okay, let's do another one.
Everything?
Everything. On all 5 problems. Okay, so what are the different types of a parallelogram? So first of all, a general parallelogram is what? How many sides?
4.
4. So if I were to draw just a picture of a parallelogram, it would look like this, yes?
Yeah.
It would have this side and this side would be congruent, yes? This side and that side would be congruent. And then this angle and then this angle. And then this angle and that angle. That's just a general parallelogram, isn't it?
Yeah.
But there are 3 specific types. Anybody give me one?
Square.
Square,
Like Ryan said.
Rectangle.
rectangle, yep, and a rhombus. So we need to know the characteristics of these because the next problem it says, what type of parallelogram do I have? It can be a general parallelogram or it can be specific. So a square, what do we know about a square?
All sides are the same.
All 4 sides are the same, and
Square.
what? What are they though? Specifically,
90 degrees.
they're 90 degrees. So all the sides are congruent and all 90-degree angles, correct?
Yes.
Okay, what makes a rectangle a rectangle?
A pair, like 2 sides.
2 sets of parallel lines. So this is parallel to this. Well, it doesn't have to be because a square is technically a rectangle. A square is a rectangle, but not all rectangles are squares. Okay?
All rectangles. Wait,
There's one more thing.
don't they have 90-degree angles?
They have 90-degree angles.
Knew it.
So a rectangle and a parallelogram are the same thing, except a parallelogram doesn't have to have
That's a rhombus.
90 angles. Now what's a rhombus?
It's slanted.
It is. We usually write it like this.
A quadrilateral with
Diamond.
Diamond.
sides parallel and all sides the
Diamond
same
in
length.
the rough.
All sides are what?
Same length.
The same length. So that's similar to the square, but a square, the angles have to be 90 degrees. And a rhombus, no. A kite is not,
No, it's a diamond, Henry.
a kite is not a parallelogram?
Martin on.
It has two sets of congruent sides across from each other. So a kite,
The kite has like five.
no, a kite looks like this.
Yeah, 5. Huh?
These sides are congruent and these sides are congruent. That's what's different about a kite.
I see.
Okay? So, do we need to know the specifics? Yes. That's why I put kite on there. That's why I put trapezoid on there. Square, rectangle, rhombus. Because you have to know the specific things that make them. These shapes are shapes that you guys are going to encounter the rest of your life. Okay, so now, in order to know what type of parallelogram this is, I'm going to have to know lengths, correct? And angles.
Right.
But I can know angles if I know slopes, correct? Because these are perpendicular, correct? Right angles, perpendicular. So we need negative reciprocal slopes. So we're going to have to find all the lengths and all the slopes. Which one do you want to do first?
Probably slope.
Probably slope. I have a picture. Is it easy to count on the picture? Look at example 4. Do you have a picture?
No.
No. So on example 4, do you have to do the slope formula 4 times? Yes. Okay, so we're going to do slope first. So RS, sound good?
RS.
What do you guys get for a slope?
Do it real quick.
What do you get the slope for RS?
3/1.
3/1 or just 3? Which one do you want to do next?
RT.
RT? RT is not... RT is like the diagonal.
RU.
Oh, I didn't see the U, so.
Okay, RU? I get -4/6. You guys get -4/6?
Yeah.
So we probably should make it into what?
2/3.
-2/3?
If they're both negative.
If they're both negative, it would be a positive. Correct? Now, but RU goes down, doesn't it? Should it have a negative slope? Yeah. If you got a positive slope when it went down, either they drew their picture really wrong, and if they drew their picture wrong and we were counting, then it would be wrong, right? Like, that would not even work. Okay, next, what do you want to do? UT? What do you guys get? 3/1 or just 3?
And then you probably get negative.
And then we need ST. I got -4/6 again, didn't you? So -2/3. So, well, I know that RU and ST are parallel, don't I? And I know that RS and UT are parallel. But they told me it was a parallelogram, so I should have known that those would be a parallel, correct? But what I was looking for is if these were perpendicular. Are they perpendicular?
No.
Is 3 perpendicular to -2/3? No. One's positive, one negative. That's on the plus, right? But the reciprocal of 3 is 1/3, and the reciprocal of 2/3 is 3/2. So did I get that? No. So is it going to be a rectangle or a square? No. Is it going to be a rectangle or a square? No, it cannot be, because it doesn't have what? Right angles. Could it still be a rhombus? Yes. Now, this picture doesn't look like it's a rhombus, but you know when you're in Word and you don't pull the corner to make the picture change, you pull a side or the top, does it distort it? Yes. So don't believe the picture, do the work, right? So we need to find the length of all of those. So how do we need to find the length? What do we need to use? What did we just use? A bunch. Distance formula. So we need the length which is the distance formula.
So we do
So we're going to have to do SR or RS. Can we do the subtraction not on the paper, or do you guys need the subtraction on the paper? You guys want to do them on your own? No? Okay, so I have 2 minus 1, right? Squared plus 8 minus 5. So 2 minus 1 is 1. 1 squared is 1. 8 minus 5 is, squared is 9. So I have the square root of 10. Now, I already know that RS and UT are parallel to each other, correct? So I personally am going to do the length of UT next to the length of RS. Just what I'm going to do. Okay? So UT. So UT. So 8 minus 7 is 1. So I have 1 squared. Plus, now do you see what I'm saying about doing the subtraction on the picture? 4 minus 1 is 3. So 3 squared. So 1 plus 9 is 10. So those are congruent. That's nice, right? Now you got to do ST. And RU. And I'm going to let you guys do those both. But do you see I did one like showing more work, right? And showing a little less work. But am I showing my work? Yes. So you guys do R,
kind of.
RU, and ST. It'll be so much easier to look at your paper. Yes. Oh, those shouldn't be 4s. They should be what? 2s. I didn't take the square root, did I? Is that what
Yes,
you're...
I did that right.
Sorry, Shaylee. Thank you for telling me. Okay, so opposite sides are congruent. Well, we didn't have right angles.
36 plus 16 would be 52.
That's what I got.
Oh my gosh.
I was looking at
It's 2 squared of 13 though, right? I don't know, I got 4.
I got 2 square.
Should be 2 squared of 13. Yeah. We did 52 on the front, got 2 squared of 13, didn't we? Now, do you notice when I was doing my work, I got 6 squared plus 4 squared. Well, I didn't even do the second step, did I? Maybe I would have caught my mistake if I would have. But I'm doing the work. I don't need to keep repeating the same work, do I? Just set it up. So is this any special parallelogram? No, it's just a parallelogram. Oops. So it's just a parallelogram. But what if this thing asks you for the area? Well, if they would have asked you for the area, would you still had to find this? Yeah. Well, actually, you'd only have to have a length and a what? Because it's base times height, right? So do I have a length and a width? Yeah. I have what? Square root of 10 and 2 square root of 13. So then I've got to, well, this would be 10 times 13 is what? 130. Now, does 10 or 13 have any common factors?
No.
No, 10 is 2 and 5, right? And 13 is 1 and 13. So am I going to be able to simplify 130? No. So this would be 2 square root of 30 units squared, whatever the units were. But do you see how they can ask you other questions? Yeah. So, if you're confused on what it's asking you, well, the first one says, what's the perimeter? Well, if you want the perimeter, don't you have to find all the lengths and add them up? Yep. And this second one says, what type of the quadrilateral are you having? So you have 2 shapes, guys. 2 shapes. So that means you're going to have to find the distance formula and the slope of every line. There's 4 on the top, 3 on the bottom. So 7 distance and 7 slopes. Can we do that? If you have questions other than that, but I want 7 distance and 7 slopes. And we can go from there if we don't know how to classify. Make sense?
Yeah.
How many distance? How many slope?